All right, in this video, we're just going to look at some examples of sets, and then we're going to look at a few names and notations of special sets, so hang on for that. But just some random examples of sets. We could do some roster method examples. I could do like the set containing A and C and B, F and G. Right, notice we started with curly braces, which indicated it was a set. We listed our elements separated by commas, and then we put a closed curly brace. I could do sets with numbers in them, so it could be like 10, 15, 20. We could have sets that only have one element in them, so I could have like the set only containing 4. We could have words be a part of our set, so I could have something like the set containing dog and cat. Notice all of these have been roster method examples. We could do, say, another set builder example. We could do something like the set of all x's such that x is odd. Or likely there what we mean is that x is an odd number, so things like 1, 3, 5, -1, -3, -5, things like that. So all of those would be examples of sets. So clearly we have lots of flexibility of what we can do. We can even do really interesting things where we can have sets that themselves contain other sets. So I could have something like the set containing 1, 2, 3, and it also contains the set of 1 and 2. Notice it's in the list of things. So sometimes when I think about sets, to help me picture it, is I think about a set like a box that contains stuff. So it's like a box that then I've put stuff into. So what this one would look like is inside of this box, there's the number 1, there's the number 2, there's the number 3, and then also inside of that box is another box that contains the numbers 1 and 2. So you can have sort of nested boxes. You can have nested sets. So we'll kind of talk about that a little more later. But for a minute, I want to talk about a few examples of special sets. There are lots of these that come up, but we're just going to look at a few of them. Basically, they're common enough examples of sets that we give them a special name and sometimes a special notation so that we can reference it faster than having to say its full description. So the first one we can look at is the set of all whole numbers greater than or equal to 1. So you could also call that just all of the positive whole numbers. So 1, 2, 3, 4, 5, 6 on to infinity. The special name this one gets called, it's kind of fun, is the counting numbers. You can kind of remember what's in the counting numbers, because if you think about a little kid counting, right, they go 1, 2, 3, 4, and then keep going on from there. So that's the set of all counting numbers. So in a way, just saying the phrase counting numbers is a verbal description for the set. We could instead write it in roster method. So in roster method, right, we'd use an opening curly brace and then write 1, 2, 3. In this case, we would have a ... that doesn't have anything after it because it keeps going infinitely. So we would imply that by just having no end, it would just keep going. We could, if we want, use set builder notation. And this is kind of an example where it might be helpful. So set builder notation for this one could look like the set of all x such that x is a whole number and we could write x is greater than or equal to 1. So notice over there, sorry, I got a little close to the edge of the board there. When we write this, rather than having to verbally say x is greater than or equal to 1, we could use this symbol greater than or equal to 1. So another thing we'll kind of notice is you get to reference that x multiple times if you want to. So the counting numbers. Our next one is a really, really important set that we're going to use fairly frequently. It's this idea of what if we have the set with no elements. So literally it's like I have a set, but there's nothing in it. Now, and fairly intuitively, it's called the empty set. So the empty set is the name of that one, because it kind of makes sense. If there's nothing in it, then it's empty. That's the name for that set. It can also have other names. Sometimes people call it the null set, N-U-L-L, but I'll typically call it the empty set. It has a symbol that we use to notate it. The symbol that we use for it, it kind of looks like a 0, but then it has a slash through it. Some people actually draw their zeros that way. I'm going to ask that, at least in this chapter, that you save that symbol specifically to mean the empty set. So it is a set, and it just contains nothing. If we think about what it would look like in roster method, well, roster method says, okay, to write that it's a set, you do an opening curly brace, and then you list all of the elements, but there are no elements here. So we don't list anything, and then to end the set, you put a closed curly brace. So just an empty set of curly braces would be the empty set. So it's the set that contains no elements. Now, one of the things that we're going to notice is any of these 3 ways are great ways of describing it, right? Verbally, the empty set, you can use this special symbol of the 0 with the slash through it, or empty brackets, empty curly braces. But we don't want to mix any of those things. So note, if I do something like this, if I do a curly brace and then put that 0 with a slash through it, this is not the empty set. Now we might think about, why is that the case? Well, if we literally read what that is, because we know how to read sets now, the curly braces indicate to me, well, this is a set, and then anything listed inside is an element of that set. It's something that's contained in the set. So notice there is something inside, right? Just like this one, this is the set that only contains the number 4. This is the set that contains the empty set. Now, that's kind of a weird meta thing to think about, but notice it's the difference of an empty box versus a box that contains an empty box, right? The first box isn't empty. It has something in it. It just happens to have another box in it that's empty. So this or this, not this. So this one is not a correct notation for it. So those are not the same set. They are different than one another. What we're going to do at this point is you can pause, you can stop this video, and you can jump on to the next video. Before you do it though, you're going to grab your worksheet for section 2.1, and you're going to try the first question on that worksheet for section 2.1. I would recommend trying to do that example first on your own, kind of the same way that we would have in class. And then as you need maybe some pushes in the right direction, some hints, you could start the next video where I'm going to be working through the solution of it. You might pause once you get enough of a push in the right direction. And then once you've finished your example completely, then watch the full solution. So then kind of finish out that other video. And that's kind of in general how I want you to work through those worksheet videos, is to try the examples on your own first, and then kind of use the solution videos as a guide to either give you those hints to push you in the first direction, or once you're finished with your example to see what the full solution was and check yourself to make sure that it was right. So hop on to that video when you're ready for it.